So this is section 6.4, although this problem right here says it's 6.3. And the reason why is because this is a problem from 6.3 that we did involving the volume of air in the lungs in a 5-second respiratory cycle. In that problem, we were asked to find the volume of air in the lungs at 1.5 seconds into the cycle. So you remember we took each T and replaced it with 1.5, which is how you evaluate functions. That's what you do. As we did that, then you take all of this, you cube the 1.5, you multiply it by the negative, and you got this. You continue here, you do the 1.5 squared, and then you multiply it by this. And then you multiply the 0.173 times the 1.5, and you get this. Put them all together, and you get this. Remember, I think the answer that we had that day in the answer key, or in that lesson, was 0.4766, but you can see that's rounded to the nearest 10,000th answer. And that's what we did, and we've been doing those kinds of things for some time as far as evaluating functions for a particular number. And what I want to do is I want to look at the same exact problem, but I want to play around with synthetic division. And so I'm going to take the coefficients, and you'll see those are the coefficients. And I'm also allowing for the fact that there's no C or number at the end. It's got T to the third, T to the second, T to the first, but there's no T, so I put a space holder here. If we apply then the synthetic division process using this as our synthetic divisor, we bring down our first term, we multiply, we get the negative 0.0555. Put those together, you get that. Then you multiply the 1.5 times that, and you get the 0.1447, and then you get that. Then you multiply again, and you get that, and you get that, which is exactly the same thing we got the other way. So we were evaluating at a particular value. We're doing the function at 1.5, but if we had done synthetic division, we would have got the same exact answer, which just suggests to you that it works, which is a nice suggestion. So if we take this function and we do, here's the function, the f function is here, and we're going to do f of 2. So we take out the x, we put in the 2. So everywhere we see a 2, everywhere we see an x, we're going to put in a 2. So 2 squared minus 5 times 2 plus 6. So that's 4 minus 10 plus 6. That's 0. If we did synthetic division, our coefficients are 1, negative 5, 6. A 1, negative 5, 6. Our synthetic divisor is 2, so we use 2. So I bring down the first number, I multiply, I put those together, I multiply, it's a negative 6, and I get 0. So if I evaluate at 2, I get 0. If I use the synthetic process, I get 0. In other words, I could have used the synthetic division instead of this. And I get the answer. And that leads us then to section 6.4, which is analyzing graphs of polynomial functions. We're going to graph polynomial functions and locate their zeros, and we're going to talk about relative maxima and minima. Relative maxima here and relative minima here. Each of them in their own way, maximum, minimum, each of them in their own way is going to suggest that there are no other points nearby, and that's kind of these two pieces here. No other points nearby that are like them. Either no other points nearby that are greater, for the relative maximum, or no points nearby that are less for the relative minimum. Let's think of it this way. Take the richest person in Norton, not the richest, I don't know who it is. Take the richest person in Norton, or in your town if you don't live in Norton. Take the richest person, richest. Compared to everybody else, their relative maximum, the richest. But compared to Bill Gates and Oprah Winfrey and some other sort of major rich people, not so much. So they're relatively rich. In other words, they're rich based on where they are compared to the people in the place where they are. But you get them out of the area, you put them in another place, they're not that rich. They would actually be quite not rich compared to some of the other people that are there. So that's the kind of thing that we're talking about. I mentioned in a previous lesson about turning points. We talked about how many turning points. So we'll look at that. It's this place where a graph turns. So we're going to graph this by making a table of values, or at least that's what they propose that we do. Graph it by making a table of values. And I'm not saying we're not, or we can't, but because we can. We do know it's going to go through 5. And a normal cubic looks like this, but because the leading coefficient is a negative, it's going to flip it over. Now, it's going to flip it over, and it's going to look something like that. So a good thing for us to do is to plot a few points. So let's try -3, -1, 0, 1, and 3. Now, if I've got a calculator in my hand, so I hope you have a calculator accessible to you, and I'm gonna go ahead and put this function in. I'll raise it to the 3rd power. You can't see what I'm doing, I realize. So actually I do actually realize that. But I'm just doing it because I want to share a little something with you. So looking at the set of points here on this chart that I've created in my calculator, -3 produces a -4, -2, which I didn't use, produces a -3, -1 produces a +2. So let me just note that there's got to be a 0 somewhere here between these two, because you went from negative to positive world, so you have to cross the y-axis. 0, as we said, produced a 5, so we're not shocked by the y-intercept. We knew that. 1 produces a 0, so there is a 0 at a nice sweet place. And then 2 produces a -19, and 3 is a -58. So I don't think I'm going to be graphing either one of those. If I had waited to look at the table, then I would have done that, and there's another 0 between those two. So what that does is we have -4, +5, and then we have -3, -4, and we have -2, -3, and we have -1, +2, 0, 5, and then there's a 1, 0. So the graph is going to go something like this. which is a bit like what I predicted it would look like. You never know how much this piece in the middle is going to bump or bubble. Not sure how high the hump's going to go. But that's approximately what that looks like. So it says graph doing that. So here's their table of values. You'll recognize those as things that we just had. You'll see that I have previously noted that there's a change from negative to positive and positive to negative. And then, of course, we know that there's actually a zero right there. So their graph is going to look a bit like ours. A bit like ours. Now, with the calculator, it's great. Oh, hold on a second. So I'm not paying attention, am I? All right. So I don't remember them asking us these questions, but there they are. So this is an odd function. We know it's odd because it's an odd function, but we also know it's odd because it has opposite end behavior. One's going to heaven, one's going to not heaven. So you'll see that they have noted that, and this is how I would have written it. I would have written that first, is x goes to negative infinity. Dun, 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 dun. Where's y going? Well, it's going up through here, right? So it's going to be positive infinity. And as x goes to positive infinity, dun, 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 off this way, where's y going? Well, way down here. And so that's negative infinity. And so I do want to at least look at this, because what they have right here, it says, notice that the sign intersects the x-axis 3 places, indicating that there are 3 real zeros. So 1, 2, 3. It would appear that this one is between. This one is between. Like it's not at -1 or -2. It's between -1 and -2. This one appears to be right at. In fact, we know it's more than appears, because we remember we had this point, which is represented by this point, or this ordered pair represented by this point. Okay. So we carry on. If we have a calculator, graphing this is easy. If not, we got to use a table. Using a table can be some work. I will say that I'm pretty sure, since the a is, or the leading coefficient is positive right here, the answer is going to be C. I do know the y-intercept's at 1, so that's good. That's good. That's good. That they all have that. So since it's odd, it's going to have opposite end behavior, so that puts this one in the no list. These do not have opposite end behavior. They're both going to not heaven. That puts it in the no list. So it has to be A or C. Has to be A or C. So I would suggest then that we pick a point like this one, which they have suggested is -2, 1. And we put a -2 in here and see what happens. -2 cubed is -8. -2 squared is 4 times 2 is 8 plus 1. And you can see that that is 1, and that's what we have. And so the answer is C. Now, the location principle. Suppose y equal some function represents a polynomial function, and a and b are 2 real numbers, such that f of a is negative and f of b is positive. That's that thing that we talked about back up here. Then there's got to be a 0 between -4 and -3. There's got to be a 0 between -2 and -1. And so when we looked at our graph, we saw there has to be a 0 between -3 and -4. There has to be a 0 between right here between -1 and -2. There has to be. So that's what this is talking about when they say if one value is less than 0 and the other value is greater than 0, then something had to cross the x-axis. So there's at least one real 0 between those two numbers. to help you see it over here, they're saying it's negative here, it's positive here. So there has to be a real zero in between. Somewhere between the A and the B, there has to be a zero. So it says determine consecutive values of x between which each real zero of this function is located, then draw the graph. So I'm going to use their table this time. Looks a little bit like our table from the previous problem, but it's different. And they just either generate it by hand or generate it with a calculator, but we've got it. I will say that there should be 4 real zeros, or 4 zeros. There should be 4 zeros. And so there's either 4 real, or 2 real, or no real. And that's before we even look at this. 4 real, because there's going to be 4, so it could be 4 real. 2 real, because 2 of them could be real and 2 of them could be imaginary. Remember, imaginaries always come in pairs. Or if all 4 of them are imaginary, then there's no reals. So that was our just like initial analysis before we look at the table. But by looking at the table, we have a sign change. By looking at the table, we have a sign change. By looking at the table, we have a sign change. By looking at the table, we have a sign change, which tells us that there is a 0 between -2 and -1. There is another 0 between -1 and 0. There is another 0 between 0 and 1. And there's another 0 between 2 and 3. Oops. I did not mean for that to stop. Okay, so then they want us to draw. All right, so I'm gonna just sneak this little graph in right here, just for the purpose of our discussion. So I'm gonna call this -1. I'm gonna call this -2. I'm gonna call this 1. I'm gonna call this 2. This is 1, 2. Well. And this is -1. This is -2. Watch. I don't know how close this one is, but somewhere between -2 and -1, there's a 0. Somewhere between -1 and 0, there's a 0. Somewhere between 0 and 1, there's a 0. And somewhere between 2 and 3, there's a 0. So I've got that right away. I also have this, which means there's a 0, a y-intercepts at 1. So I'm already getting some ideas about this graph. Because this is positive, it opens up. So it's going to look something like this. Like a W. So let's plow on through. They noticed the change in signs. That's what we said at those particular places. And they've got a nicer dip than I do. But because they actually graphed the points, I did not. But we get the idea. Determine consecutive values of x between which each real zero of the function is located. How would we do that? Probably a table. So if we do a table, and without a camera I can't show you my calculator, so hopefully you got a trusty handy dandy calculator that you can put this stuff in, or something on your phone, an app on your phone or something. So I'm just looking and I see a -1, -3, I see a 0, 2, a 1, -1, a 2, -6, a 3, -7, a 4, +2. Now, I do expect that there are 3 zeros, which means there's either 3 real or 1 real and 2 complex. But looking at the table, there's a sign change here, so there's 0 in between those two, the -1 and the 0. There's a sign change here, so there's a 0 here. And there's a sign change here, so there's a 0 here. So there has to be a 0 between x is -1 and 0. Has to be a 0 between x is 0 and 1. There has to be a 0 between 3 and 4. I believe the answer that says that is B. Estimate the x coordinates at which the relative maxima and minima occur. So we're looking at this table of values that goes with this function. And we know there's a 0 here because it passes from negative to positive. There are no other places on this table that indicate a change from negative to positive, positive to negative. I'm not saying it doesn't happen. I'm saying there's not one on this table. And there's a possibility, just if I could just quick graph this, there is a possibility that the graph looks something like that. So there is only the one real 0 and the other two are imaginary. But we said that that was a possibility in the beginning. Now, when we graph that, then you see that, like when we graph this whole table of values, you'll see that that's how that worked, that it didn't go back down below the x-axis, so there's just this one real 0, and the one real 0 is between -2 and -1, and that is, in fact, exactly what we see between -2 and -1. It's close to -1, but it's not exactly that because -1 did not produce a 0 in our table. Then you come up and you go back down and you go, so can you understand that in this area right here, this is the maximum. It's a relative maximum because there are numbers that definitely go up higher. But in that area, E's the boss. Okay? Then we come down here and then we go back up. So again, we have points that are lower than this because this goes all the way to not heaven. But as far as in this neighborhood, this is the lowest guy that there is, relative minimum. It goes back up. So you can see that that occurs when x is 0 at 5 and when x is 2 at 1.